Hey guys, so I've been messing around with Segment Anything 3D and Depth Anything 3, and I'm just going to be walking through some of the stuff I found. So Segment Anything 3D, or SAM3D, has two parts. The first one is the main thing I'm talking about in this presentation, so that's Segment Anything 3D objects, and for that you pass in an RGB image, a segmentation mask of an object in that image, and optionally a point map, and it'll generate a textured mesh or a Gaussian splat of the object as shown on the right here. The other thing that they released was Segment Anything 3D body. And so in this case, you'll pass in an RGB image and a segmentation mask of a person in that image, and then it'll generate a mesh of the person. So what's shown on the right here is a Gaussian splat of the coffee with the coffee filter on it that I got from running this on Meta's own website on their demo. Unfortunately, though, they don't allow you to actually export this, so I'm not sure how good the scale of this might actually be. So for testing it in the real world, we're testing it on some data I collected in the lab. So I collected a scene with the Z2i stereo camera. So this is the image of it on the left. And I took a segmentation mask of just the coffee maker on the right. I then also collected the ground truth depth image from the Z stereo camera as shown on the left. And I ran depth anything 3 on the RGB image of this scene to get the inferred metric depth map of that. So now I'm just showing off our real-to-real turn-into-real assets versus SAM3D. So column by column is real turn-into-real, so those are the assets we used. Next is SAM3D when we prompt it with no depth information. Then third column is SAM3D if we prompt it with the ground truth depth information. And finally, the fourth column is if we prompt SAM3D with the depth anything 3 depth information. So as you can see, first row is the Gaussian splats. A big change between real turn-into-real and SAM3D is that their Gaussian splats are very, very dense. There are no holes or any artifacts you can see in them. And so it's very interesting how they're able to get that done. The next thing is for the textured meshes. If you see that the textured mesh we actually used for real turn-into-real was like very holy, like the texture of it was quite rough and poor, versus for SAM3D, these textures are quite good. So something to notice though is that the scales are wildly off. So if we look at the image here, real turn-into-real, this is the textured mesh we have, and this scale of this mesh represents the true scale of the coffee maker in the real world, versus if we compare it now to the scales of the meshes generated by SAM3D no depth, SAM3D with ground truth, and SAM3D with depth anything 3, the scales are way off. So these generated meshes from SAM3D are on the level of meters, and they don't at all represent what they actually should look like in the real world. So an idea though is, okay, what if we actually rescale them to the ground truth? So since we know the ground truth dimensions of the coffee maker, we can actually just rescale these meshes to this amount. So I did that both for SAM3D meshes and also for Curie, which was the new approach that Hudson found, which also allows you to pass in multiple images of a scene and it will reconstruct the textured mesh. So here are the results from left to right is real turn-into-real. So this is the original textured map that we used for our stuff. And then we have the Curie, which was Hudson's approach. So if you notice, the scale is slightly off from the ground truth. It's a bit larger. So I rescaled that down to get Curie rescaled, which is the accurate dimensions of it. And likewise, I also rescaled the SAM3D depth anything 3 version of the textured mesh. So these look a good bit better and be exciting to actually see how they work in real turn-into-real. Another thing I also tried was testing SAM3D on the OmniScan objects. So if you remember from OmniScan, we generated a bunch of Gaussian splats of a lot of different objects. A lot of them were very unique and interesting geometries. And so now the question is, okay, how can SAM3D do with these objects? So I passed in these as images into SAM3D, and here are the results. So these are the textured meshes. As you can see, they're pretty good, or they're at least very interesting. So one thing it seems to struggle a lot with is text. So a lot of the text, say on the flashlight or on the wire plug tester, are quite uninterpretable. Like it's sort of gibberish, but nonetheless, the overall like texture of everything is quite robust. So it's definitely very interesting to look at and definitely worth pursuing more. And so some issues I had with SAM3D, the main issue is that it only supports a single image for inference. So even if we had multiple images of an object, we couldn't give multiple to SAM3D. So the end result of this is, right, the input image we gave was shown here of the coffee maker, and we don't really see the backside at all. So with Curie, since it's multi-view, we know that the actual backside of the coffee maker like goes straight down and there's a little thing at the end. However, for SAM3D, what it does is just sort of rounds this off, which is a fair assumption to make, but isn't actually what the object is. So some questions I have are, how do you actually get support for multi-view? And the second thing is, does it actually matter? So for the first part, I think it is possible to, maybe without changing the model architecture, we could generate two Gaussian slots with SAM3D and then try and train a merged Gaussian slot similar to OmniScan and sort of see how that works. For the second question of whether it actually matters, I think it depends heavily on the task. So if you wanted to actually like do like in-hand manipulation of an object, right? Then in that case, if you only have one view of the object and then it generates something maybe wildly off, so that SAM3D does, then when you try to manipulate this object, the other side you have would not be accurate to the real world. However, if this is more so you only are manipulating stuff on the side of the object that you've observed with SAM3D, then it does seem to do a pretty good job, in which case it seems like it should be more than good enough.